Thank you again for joining this special session of Shadow the Scientist. My name is Jamika Marshall. I'm the Shadow the Scientist Programs Manager. Shadow the Scientist is an initiative brought to you by an incredible team at the University of California at Santa Cruz. Now, you are in for a special treat for this special Gemini user session. Now, I'm sure that many of you already know, but in case you aren't aware, the International Gemini Observatory consists of twin 8.1 meter optical infrared telescopes located on two of the best observing sites on the planet. Now, the Gemini North telescope is located in Hawaii's Maunakea and is a part of an international community of observatories. By incorporating technologies such as laser guide star adaptive optics and multi-object spectroscopy, astronomers in the Gemini partnership explore the universe in unprecedented depth and detail.
Just a heads up, today's video.
Our observations will be taking place in the control room, and that is at the Hilo Base Facility. Now, this session is being recorded and it will be posted on the Shadow the Scientist YouTube channel for later viewing. Now, I'd like to welcome our science hosts, Brian Lameau, Denise Hung, Siyi Shu, and Zachary Hartman to get us started. And I believe we're going to begin with Brian Lameau. Brian, welcome.
Aloha, Jamika. Good morning. I know everybody's joining from all over the world. We have people here from the west coast of the US and Canada, and then everywhere else in the world. But yeah, so we're here in Hilo, Hawaii, on the Big Island of Hawaii. I am in the Gemini North base facility control room right now. So, hi. I'm the one with all the computers, or at least half of the computers in the room. The other half belong to Denise Hun over here. She's our operator for this evening. So we're the night crew for Gemini North. So we're actually actively taking observations right now. As I mentioned in my email, it's a beautiful night on Maunakea. This is not abnormal for Maunakea. That's probably why a lot of you proposed for telescope time, either on Gemini North or Gemini South, because we do have two of the best observing sites in the world. This is what it looks like from our cloud cameras right now. So we're looking off the east ridge of Maunakea towards Hilo here. So we're about 20 miles away, or 40 kilometers in God's units. This is the summit area, and this is the two Keck telescopes, the NASA Infrared Telescope Facility. This is what it looks like straight up right now. So absolutely zero attenuation. Gorgeous skiing. We're getting seeing of about 0.3, 0.4 arc seconds in the visible right now. So everything you could ever want as a PI. And right now, actually, I'm actively taking observations. We're doing an IGRINS 2 observation of a planet transit. So I'm gonna actually shift over to CE now, and I will go back to operations, and I'll kind of just jump in and out as we take new observations. So I'll pass it over to you, CE.
Yeah, great. Thank you, Brian. Fingers crossed. Yeah, hello everyone. My name is Siyi Shu. I'm an astronomer at Gemini Observatory, and I have worked in science operation and in Hilo for 7 years. Recently just moved to Tucson. So right now I work more on user support and the community engagement. Yeah, thank you very much for joining us for this Shadow the Science session. So we prepared some slides, and I'm just going to go ahead. Jamika, could you please confirm you can see my slide?
Confirmed.
Awesome, thank you. Yeah. Well, all right. I guess we've gone through that, so we're just gonna get started. Well, yes. So just some very basic outline of this session. This is pretty informal, so please feel free to ask questions, raise your hand, or type in the chat. A brief outline is we have prepared some slides. We will go through them. So since this session is more geared towards phase 2 preparation, because we know the deadline is this Friday, so we're going to go through some basic of the observation, and then Zach and I will show some examples about phase 2 preparation. And also in between, anytime when it's a good time for Brian to show us how the actual observation is done, he will basically jump in. And no, okay, no special question. Right, any questions before we move on?
No questions in the chat at the moment, but I will just remind you, as Brian has just posted, feel free to introduce yourself in the chat, your science and the instruments you're interested in, as well as anything that you'd like to see or discuss during the session.
Yeah, thank you, Jamaica. All right, let's keep going. Right, so Jamaica actually already gave a really nice overview of Gemini. So we are named Gemini because we really have two twin telescopes, one in Hawaii, one in Chile. So the idea is then we can look at both the northern sky and the southern sky. And also because of the time difference, there's a good chance if you want to observe something, one of us would be at nighttime, so we can observe your favorite target. We're really optimized for both optical and infrared. We can do both imaging and spectroscopy. And the Gemini is an international observatory, so we have quite a few partners, including the US, Canada, Chile, Brazil, Argentina, Korea, and the University of Hawaii. And then since about 2020, it is also part of NSF's NOAA lab. And here is just the images of Gemini North and the South. I know when I look at it, I will always get a little bit confused which one is which. So Jamaica, do you know which one is Gemini North and which one is Gemini South?
Yes, I think the one on the right is Gemini North and the one on the left, Gemini South.
I think so, because I usually see the Magellanic Cloud, right? So I think that's usually
That's what
how I
tips you
see
off,
it.
huh?
That's it. That's the tip off.
Exactly.
Yeah.
It's got to be
Okay.
it.
Yeah, but otherwise they look pretty identical. So yeah. All right. If this is a basic overview, I'm just going to move on to the next slide. Yeah. So Gemini we have quite a suite of instruments. We can do a lot of things. So if you want to learn details about it, there's a link. I think the slides will be posted later. But just quickly, we do both optical and infrared, actually also mid-infrared, not only near-infrared, mid-infrared as well. We have both imaging and spectroscopy. And imaging with GMOS, the largest field of view would be about 5 by 5 arc-minute field of view. And we also have speckle images, ALTAIR and Zorro. Zach is really an expert on that. We can do very short exposures for high resolution observations. And spectroscopy, we have many different modes, long slit, integral field, multi-object, both high and low resolution. And in terms of guiding, we also have the AO capability, both at Gemini North and Gemini South. We can use either laser or natural guide star to correct for atmospheric distortion. Yeah, then just going into a bit more of the details. In a way, the instrument at Gemini North and the South is somewhat mirrored. So for example, like GMOS, we have one both at Gemini North and Gemini South, and they are basically the same. Yeah, they are pretty much the same. Yeah. So here we're breaking them into optical, infrared, and the AO guiding. So for Gemini North, where Brian is at right now, optical, we have GMOS, which is really very versatile. It does a lot of things. It's kind of among the most demanded instruments. It does both imaging and spectroscopy. And then the counterpart at Gemini South is GMOS South. And then there's ALTAIR, which is a speckle and a rapid wide field imager. And the counterpart at Gemini South is called Zorro. And then at the Gemini North, we also have MAROON-X, which is actually still a visiting instrument, but it's also very popular. It's a high resolution spectrograph, and it is optimized for performing radio velocity studies of extrasolar planets. So you can really constrain the mass of those extrasolar planets. And it can also be used to characterize the atmospheres of extrasolar planets. So really very planet focused. Then in the
I'll just mention, see that So right now we're taking an IGRINS-2 observation, which is, I guess you're going to talk about soon, but in about 10 minutes, we're going to shift over to MAROON-X, so people will be able to see it in action for the rest of the night, actually.
Perfect. Thank you. Yeah. Yeah, then we're going to move on to the infrared. We have GNIRS, which is a long slit cross, which is an infrared spectrograph. It mostly do spectroscopy, but it also have 2 integral field units and then a small pinhole imager if you want to do some quick imaging. And IGRINS-2 is the latest addition to Gemini North, and it's our newest instrument. It is a high-resolution near-infrared spectrograph. It's actually provided by Korea. Yeah, and it just finished the system verification and it's in science operation right now. And then at Gemini North, we have ALTAIR, which is our AO system. All right, maybe I'll make a pause here. I feel like that's a lot of information. Are there any questions about general Gemini instrumentation or Gemini North?
There are no questions in the chat at the moment, but if you're just joining us, I'd like to again welcome you and say that you can raise your virtual hand if you have any questions, or you can direct message me and I will share them in the chat for everyone. Thank you. Thank you, CE.
Yeah, thank you. And so maybe another thing worthwhile to mention from the PI's point is we do have a lot of instruments, so not all the instrument is on at the same time. So certain things are more block scheduled, like MAROON-X. So as a PI, when you prepare your program, you should really look into the Gemini schedule, which is on the website, and it will post to say at what time which instrument is available. So that probably is the single most determining factor for you. Let's say if you want to use MAROON-X, I don't know, in September to observe your favorite planet, but the MAROON-X is not on the telescope. That would be a problem. And it's also a concern, say, if you want to put in a fast turnaround program or a DDT program, right? You really want to make sure like your instrument is actually, the instrument you want to propose is actually on the telescope.
Maybe I could, if you stop sharing, I could show the last photons that are going to come in for our IGRINS-2 observation right now. Let me see if I can share it really quick. Okay, so this is us on Sky right now. So this is the IGRINS-2 observing application. It used to be, not too long ago, at Gemini, all the facility instruments had one way of acquiring data. Now for many of the different instruments, we have the own application, our own GUI. And so this is the GUI associated with the IGRINS-2. We're doing planetary transit observations. So I think it's exoplanet, hot Jupiter, and this is just post occultation, so it's just coming out of the background of the host star. We've been on it for about 3 hours and 45 minutes, so we're just on the last 3 frames now. So 1 2B positions and 1A position, and then we're all done. So this is a 7th magnitude star, I think. And you can see so this is the slit viewing camera for IGRINS-2. Here's our 0.3 arc second slit right in the middle. The slit is nodding up and down for 4 hours straight. And then we have this is the output from IGRINS-2. So this is our segplot software, which gives us, as observers, the ability to really quickly assess the data at nighttime. So what you're looking at here is 3 extensions of the multi-extension bits file that comes out of IGRINS-2. The one on the top left is the H-band spectra. This is R45,000. The one on the right is the K-band spectrum. So this is simultaneous. And then this here is the slit viewing camera. So this is just written out every 1.63 seconds. It just adds on extensions, effectively ad infinitum, as you're taking observations. And so this is super high signal to noise. We're getting about 2,000 counts per spectral pixel. at R of 45,000. So bright source, but yeah, plenty of signal there. So I can stop sharing for now, and then as soon as we start to acquire on MAROON-X, so we'll shift over. As CE mentioned, we don't have all the instruments on all the time, but one of Gemini's awesome capabilities is to shift instruments very, very quickly, faster than our slew time. So we'll shift over from migrants to MAROON-X in the next 5 minutes or so, and I can show the acquisition sequence.
Perfect. Thank you, Brian. Yeah. And then I saw a question. Jamika, would you like to read the question? Yeah.
Sure, absolutely. How far in advance do you or the system decide which target or instrument program to observe on a particular night? And then does the queue get updated in real time during the night?
Yeah, that's a very good question. Right now, the plan for the night is determined, is generated during the day. So we don't do it in real time. So right now, at the observatory, we have somebody on shift called, excuse me, called queue coordinator. And then the main responsibility for that person during the day is, okay, sorry about that, is to generate observing plans for the night. So the idea is you will make several variants depend on, is will make several variants depending on the condition of the night. Say very clear sky, very good seeing. This is the set of observation you're going to be doing. And then in Gemini terminology, if it's CC80, like IQ any, right? This will be a poor weather variant. That's like another variant. So this is what's happening now, but we are in the process of developing a more automated queue planning. So hopefully it will be deployed in the next few years. So basically then the computer would automatically generate plans. So we will no longer need somebody to do that. But my understanding, even with that, it will still be generated during the day, not at night. So we're not quite at the nighttime generate the thing yet. However, those special cases, let's say if you have a rapid TOO, right? I don't know if Brian will get one, or I don't know if Brian wants to receive one.
We already got one, see.
Oh, you already got one, okay.
Yeah.
So
Been there, done that tonight.
Good job, yeah. So these are kind of the most exciting or disruptive ones. So even though you have a queue.
Denise, can we slew to Q123, 164, please?
Brian, do I need to switch to you? Oh, you're good.
Oh, no, you're good.
Oh, you're good. Okay. Yeah. So if a rapid TO comes in, we will abandon all the queues, queue observations, and then just go and observe the rapid TO. Yeah. Then we'll come back.
To CE's point, we have 13 different variants tonight. So the queue coordinator was working very hard today. So we had this planetary transit. We had a rapid TO come in the late afternoon. We have all sorts of backups. We have all sorts of weather variants. And we kind of knew it was going to be really, really nice tonight. And still, the queue coordinator had to make all the cruddy weather plans just in case things happen to surprise us on Maunakea. Maunakea is it always has surprises, so it's not a bad thing to be prepared.
Wow, 13. And I just want to say the queue coordinator is actually also on call throughout the night. So if Brian have any questions or anything not clear about the queue, and he will be calling the queue coordinator, ask for clarification. So at PIs, you might receive emails from queue coordinator asking you questions too. So be nice to them because they work day and night, kind of, when they're on shift. Yeah.
And to say also at the observatory, we all kind of rotate roles. So like I'll be a queue coordinator for 1 week, and then I'll be an observer another week. And I'm also Junior's instrument scientist, so I'll randomly do that and go up to the summit for another week. And so we all kind of trade. And so I have the ability also to maybe not wake up the queue coordinator at 5 in the morning and make a somewhat autonomous decision, informed autonomous decisions, at least take a little bit of a chance, depending on how much I want that person not to talk to me the next day.
Very true. Yeah. All right. Hope that answers that question. If there's no other questions, I will go ahead and continue the presentation. Yeah. Right. So this is the Gemini North capability. So let's move on and take a look at Gemini South, which really very much parallels Gemini North. And in the optical part, we have GMOS South. So it's basically, yeah, the exact same copy as GMOS North. Actually, I should talk about Zorro next, which is exact same copy as Alopeke. So both Zorro and Alopeke is also visiting instrument. And then we have Ghost, which is the newest instrument at Gemini South, was also recently commissioned. It's a high resolution Echelle spectrograph. Yeah, can do all kinds of cool things. And they also have like precision radio velocity mode, which is to be commissioned. And if it were commissioned, it will also be able to do very high precision radio velocity studies. And then in the infrared, we have Flamingos 2, which does an imaging long slit and more recently multi-object spectroscopic observations. You need to design masks, but then it's quite efficient. And then we also have GSAOI, which is an imager to be used together with GEMS, our AO system. Then let's see. Okay, yeah. Okay. Any question about Gemini South before I move on? Okay, I think we're good. I guess we all know the instrument well. Next, right. So because Gemini is an international partnership, so we do have a lot of support from our different partners. So today we are very glad to have Eric from the Canadian National Gemini Office joining us. So Eric can tell us a little bit more about the NGOs. Please go ahead, Eric.
Thanks,
Yeah,
Ian.
sorry to interject, but maybe I could so we're just getting set up on our MAROON-X target. And it's a 30-minute exposure once we get there, so we'll have plenty of time to talk, but this is the, I guess, one exciting part. So maybe I can share that screen, and then we can get acquired and then kick back. Okay. Let me try that. Okay, there we go. So this is our MAROON-X GUI. And I'm just gonna run through the process. And I'll try to narrate as we go along. So right now, Denise just established guiding. So we have our peripheral wavefront sensor that is guiding right now at 200 hertz. And then we have MAROON-X in the center. This center region here is the science fiber. And I hope I have everything open and everything looks good. And so I'm going to try to center up that science target right here. So these are the backlit lasers. There's some reflections here. This is the star. I'll know it's the star just in case I had any doubt by asking Denise to move the telescope. So Denise, can you give me a P offset of +1? Yeah, let's try +1. Might be the wrong direction. Let's see. Is that Q or P?
It's Q.
Yeah, can you give me a P +1 and Q 0? So I'm in the telescope coordinate reference system frame now. So we call it P and Q. And in this orientation, it's roughly 45-degree rotation of the axes. So Q is roughly this direction and P is roughly this direction. Okay. Yep, sorry. Can you give me a P -1 instead?
Like, so -2.
Yeah, -2, please.
Here.
And so MAROON-X has an internal tip tilt, so I'm just trying to get it as close as possible to the science fiber. Then I'm going to start guiding, and it's going to center this up. And so within hopefully about 3 or 4 iterations, the tip tilt mirror will bring the star directly centered to the science fiber. And then we'll start the science observation. So I'm getting a photon, I have a photon counter over here. The science frames will be displayed here. And we have the etalon here that's measuring the precise wavelength solution.
We don't see your cursor, by the way.
Oh, you don't see the cursor? Okay, too bad. So at the bottom is the science frames. It's the previous observation that we took. And on the kind of top right is the photon counter. So as the tip tilt mirror starts to move, which I don't know, can you see this cursor?
Yeah.
Yeah, okay. So as the tip tilt starts to move, you can see the counts precipitously rise, and we're centered up in the science fiber now. So I'm going to take our 1800 second frame as soon as I turn on the ADC. Okay, there we go. So we are taking science now. So I'll pass that back.
Yeah, great. Thank you, Brian. Yeah, so I saw we have some questions. Yeah, so Jamika, would you like to read them out? Yeah.
Absolutely. So first, the OT gives 5 minutes for the setup time with MAROON-X. Is that accurate in practice?
Maybe I can take that one. Since I used to be the instrument scientist for MAROON-X. Yeah, I think it's pretty accurate. I mean, of course, it varies a little bit like observation by observation, but as you see, like MAROON-X setup is actually really straightforward. It's really just from the end of the observation, it's through there, and then once it's kind of point and shoot, right? So it's pretty accurate. Yeah. Great, thank you.
Excellent. And second question, can you tell us more about the offset parameters, P and Q limitations? So this person is planning to map about 30 inch squared structures through multiple IFU exposures. So they'd appreciate having those details. Thank you.
So, Brian, do you have time to take this one? I think
Yeah.
better suited. Yeah.
So I guess this is about the precision of the P and Q movement. And so okay, so the precision of the P and Q movement is quite high. So if you set it's about 5 to 10%. So a 0.1 arc second move be about 0.01%, 0.01 arc second accuracy or precision, sorry. I think the limiting factor is the differential flexure. It depends on which instrument you're using. So if you're using GMOS, the OI is essentially has no flexure with respect to GMOS. Though GMOS also is used with P2 under certain circumstances, and there is differential flexure with respect to GMOS. If you're using GNIRS, there is differential flexure between the peripheral wavefront sensor and GNIRS. You can get around this issue by reacquiring fairly frequently, but that requires a lot more overhead. The best thing possible is to have a bright source that you can centroid in your mosaic, and then just stack off of that as you're mapping something out. If you don't have that, the P and Q, the precision of the P and Q movements is not probably going to be your limiting factor. It depends on what, Diana, which instrument are you using?
Since it says IFU, I imagine it's GMOS, right? Oh, it could be GNIRS too. But if it's 30 arc second, it's probably GMOS. You might get.
Yeah, probably.
Yeah.
So GMOS with OI, you can trust that pretty well.
But actually, just for discussion, Brian, like if they want to map a 30 arc second square structure, I would imagine they would just design the pointing, right? When they design up the OT, they don't really need to use P and Q offset, right?
That's right. Yeah. It's all done in P and Q space, in the OT. But yeah, I mean, it's essentially the same thing. Yeah.
Yeah, exactly. So I don't think, just for that question, I don't think you will be applying offset like what Brian is doing right now. Basically, you already design like your pointing position in the OT. So
Yeah, so you'll do it in P and Q space, same way, and the precision will be about the same. But again, if you have any sort of bright source that you can center it up in a single exposure, then you can measure the precision yourself. But it shouldn't be a limiting factor, from my experience, and especially with GMOS OI. So yeah, so it shouldn't be a problem.
great, thank you. If there's no more questions, and I am gonna share my slide and then handing back to Eric. Yeah.
Oh, thank you. I guess I'll go. Yeah, so I'm Eric Steinbring. I'm the head of the Canadian Gemini office. And I think my role here is to describe essentially what the role of the NGOs are in Gemini. And so each of the partners, so US, NORLAB, Canada, Brazil, Argentina, Korea, and also the host partners, Chile and Hawaii, have their own office. It's essentially their like their national observatory, right? And it's typically 2 to 6 people, and we're in your host, your partner country. So these folks are effectively your first contact. We're your access to the partner's time. And so we do things like we organize the semesterly call for proposals, although not directly for the large and long program or the FT or discretionary time. But that's your pathway to getting time. We coordinate through the International Time Allocation Committee. So each of the partners has a fraction of time, and then that is put together into the queue that goes onto the telescope. So we have a representative that will work with that committee panel to create that ranked list that goes into it, and that's through your local partner TAC, so coordinating with the TAC. We don't all the time ourselves. We answer to a board representative, so our national organization, which does hold the time, but we're your advocates, right? So we want you to get time. We want you to do well with the telescopes. So we're working for you. We work for you. Typically, we do phase 1 assessment. So we do technical assessments of proposals. We're not blinded to proposals. We need to know who proposers are and can communicate with you. We want to hear from you and discuss your proposals. So at the time of proposing, we can be your contact to know the rules, and specifically for each partner, those rules can be different. So we know what the differences of slight differences in partner rules are in terms of dual anonymous review processes and what the processes are, and we're in contact with the TAC, so we can know how to help you that way. So those TAC members are actually, they're within our communities, your community. They're the ones that rank the proposals that we take to ITAC. Speaking for Canada, it's useful for you to know that we also are the communicators. We advertise. So one of our primary roles within each advertise the community. And so we're your de facto representatives as well. We organize email reminders for the upcoming calls. For example, organize sessions at like the AAS, the US, and for Canada it's CASCA. We have things like writing workshops. I know Korea does a phase 1 workshop to write proposals. We're your advocates on things like the decadal plan, and kind of the long-range plan. We also have contact with other organizations, governance organizations within Gemini too, right? So we know who the people are who are on the Science and Technology Advisory Committee. Sometimes we are members of those committees as well. And so that's also your contact, a way of getting in touch with the observatory governance as well. It's very safe to say, I can speak on behalf of the NGOs to say that please get in touch with us. We want to talk to you about you doing science with Gemini. For most cases, we're also your phase 2 primary contact. So in Canada, we have 4 astronomers. We're all astronomers. And we can cover all the modes of the instruments. We have a fairly long, I don't want to say how old I am, how long I've been in astronomy, but we've worked with many different kinds of instruments and on different telescopes as well. So we have a fairly broad experience with observing. So we will be the people that will be your primary contact for likely. And also, so that helps you get your program, working with you to get your program through phase 2. I think there'll be, you'll probably talk more about phase 2. And also, once you get your time, we will be your contact likely for help desk tickets. So for example, your primary first responder to a help desk ticket is possibly somebody in your NGO. We either can answer the question, or we know who to send it to. So we can answer that question or escalate it. So we're kind of a triage that way. But we also are a contact for your phase 3, if you will. So data reduction. So we can help answer those questions or find the right person in Gemini who really is the expert in the instrument that you're working with. But of course, our primary goal is good scientific results and good results for the partner share. So you can also look to us and directly to your Gemini, your lab, or outreach PR folks, that when you have good science, that this is advertised. Partly, that, of course, that's publication. But for press releases, for example, in Canada, within the NRC, we have a media department. And they're happy to know that you have some results. So as a contact for advertising your results, we answer to the organizations that hold the time. So when you look good, we look good. And so we're looking, of course, for programs that are thesis-based programs. We want those to succeed. We want you to get your time to complete your thesis. We would want to see high impact publications. So you can look to us to help you find contacts for that as well. And maybe just to conclude, sort of more broadly, in particular, I can say for Canada, we also want you to be successful with Gemini more broadly too. For example, if you are an instrument focused person, we can get you in touch with instrumentation groups, certainly here in Canada, with NRC or so I think that in general, the NGOs can also be more broad contacts for participation in your partner country's science, in your partner country's other astronomy endeavors as well. So I think that's true, certainly true for Canada. So I think that's kind of my overview of our role within the NGO, and I'm happy to answer questions or speak more specifically about things. But I think I'll hand it back to CE.
Yeah, thank you very much, Eric, for joining us and for that very helpful introduction. Yeah, definitely Gemini as an international observatory really appreciate all the help from the partners, and particularly the NGOs know their user community really well. So I think that really helps. Yeah. Is there any question for Eric?
No questions so far in the chat for Eric, but I will certainly let you know if any come in.
Awesome, thank you. All right, I think then I'm gonna hand over to Zach, who will tell us a bit more about observing mode and the proposal type. Zach, take away.
Yeah, thanks. All right, hey everybody. I'm here to talk about the observing modes and proposal types. So as you're observing right now, we are doing Q observing, and most of the observations at Gemini are taken in queue mode. So it is a Gemini staff member who is taking your data, and then you get the data normally day of or right after it's taken. And then you can go have the fun times of reducing it. And just like a lot of the other different modes, your targets, there are some prioritization given by attack or by some form of ranking, which I'll get into the next slide. And, we just take the data over the course of the semester. There are also two other modes that Gemini offers, both of which unfortunately come at your dime. You have the priority visitor mode where you are basically taking Brian's job and giving him a night off. And so you would come in, you would basically you would be there nominally to observe your program in a priority mode. So if you're, especially as it says, this is for band one only. So you would come in and basically that night, your program would have priority, assuming that the conditions were good. If the conditions were not good, or there was any other reason why your program couldn't get observed, or let's say your program is only for an hour and then you have the rest of the night, you would have to observe the queue. So you would get the schedule from the queue coordinator, and then you would get to sit there for 8 hours and observe your program plus everybody else's. And finally, there's also just classical mode. So, you get the night. It's the same. It's, how other telescopes used to operate and how some still do. And so, you come to the telescope, you get the night to do your science, and that's it. And so those are kind of the three modes. So let's go on to the next slide, please.
Actually, I have a question or a clarification. The priority visitor mode, right? Let's say if you request priority visitor mode, is your observation only be done during that block?
Well, I have no idea about that. That's
Okay. I thought so, and I thought that might be no. Okay,
yeah,
go ahead.
yeah. You take a shot, and then if the conditions aren't right, you give to posterity, and then maybe somebody gives back to you later in the semester.
Okay, I think that makes sense, but I was never quite clear. But let's say you requested priority visitor mode because you really would like to be there, right? And then let's say it's roughly, I don't know, 5-hour observation. You got 2 nights, but somehow the weather don't really cooperate, right? During those 2 nights. Then I guess so your observation do go back to the queue.
That's right. Yeah. It's not like a pseudo classical mode.
Okay. That's kind of very good.
It's only bonus.
I was about to bring that up.
At worst comes to worst, you're still observing with an awesome telescope. So you're doing awesome science. So you're just doing it for somebody else.
But I do think, I was about to bring up that I do think for classical mode, it is one shot.
That's correct. That's correct.
Then it doesn't go back to the queue.
Yeah, in classical mode, we strongly encourage teams to be here physically, but it is possible to do it over Zoom, though you can't. Then we have a staff astronomer also taking the observations. So it's kind of like hybrid mode.
Just to build on what Brian just said, you have to go out there. It is not unless you are a visiting instrument team, priority and classical mode you have to go to the sites. There is no remote observing anymore.
Unless we have one exception to that, Zach, this semester, but yes, it's highly discouraged because it requires us to also be observing as well. So it's almost cheating because you have a classical night, but you have a friend with you too.
All right. Let's go to the next slide, please. All right, so proposal types. You all are here because you probably got a Q program reserved, so we're not really going to talk about that. So we're going to talk about the other potential proposal types. In particular, fast turnaround is a really awesome mode that enables fast turnaround on science that, maybe you don't need it immediately, but you'd like it in the next couple of months. And so this proposal is happening, or this fast turnaround mode is every single month for most of the partners. There are some partners who are not part of it. In particular, I believe Chile is out of Gemini South's fast turnaround, and for University of Hawaii, they are out of the North's fast turnaround, but they can still apply to the South through the U.S. time. It's a really interesting program in my opinion because I mean so it's made for these programs that they're either you need them fast but not really quick. Maybe you have a trial program that you want to run, but it also can just be for any general science case. It doesn't need to be that. And the reviewers, who happen to be the people who propose, are told, it could be any science. But you could also but as you're reviewing it, you could give some more credit to those who actually want to use it for relatively fast turnaround things or uh, priority things that maybe would not be better suited for like a queue program, for example. And so, as I mentioned, if you apply for this program, you are the reviewer. You get 7 to 8 proposals, depending on how many proposals are sent in the semester, and you review them. And so, it's pretty quick because it's offered every month. So you probably have 1 to 2 weeks to get all your reviews done. And then as soon as that's done, it goes back to Gemini, and Gemini turns it around relatively quickly to send it back to everybody to get their programs ready by the beginning of the next month when your program is live. And those programs will be active for 3 months. Um, and then after that, they are deactivated, and hopefully your science has been taken. If not, you can just keep applying for fast turnaround time. Direct discretionary time is much the same as other telescopes. It's for high impact science. It's sent to a DD committee that is comprised of Gemini staff. And typically, the DD committee gets the proposals and they turn them around in 1 to 3 days. And if your proposal is accepted, then you get to go and make your program immediately, and it becomes immediately after and hopefully then taken right after you finish it. Next slide, please.
Yeah, sorry, if I may chime in.
Yeah.
I just got rotated on the DD committee, so I just want to make a comment. Is usually maybe the first thing for you to think about if you want to submit a proposal is like, should you do fast turnaround or DD? Because the DD committee would say, if this proposal is better suited for fast turnaround, they would say, why don't you try the fast turnaround, right? So I think that's just the one thing. And the one big difference is the DD proposal is open to everybody. So you don't have to be a partner country, while as Zaka says, fast turnaround, only certain parts.
Oh,
Right. With that, I'm just going to move on.
we missed your last like 5 words there.
I was just more like saying DD is open to everybody, while fast turnaround is just for certain country. Yeah, that's another difference. Yeah. All right, going back to you, Zach.
All right, yeah. So now we're gonna flip over to talking about the queue system. So there was, I believe there was a question earlier about this. Maybe let's see here. Yeah, so we were talking about how the programs are observed on a given night. So we have this program that is called the QPT, and it goes through or we go through and we basically make a queue plan for the night. So this is just a randomly selected one from I have no idea when. And you can see there's a wide variety of programs there. You can actually see that the program that is selected on the screen is actually a NIFS-AO program. So this is actually a really old uh, uh, plan here that we're seeing right here. But so the goal for this, you can kind of think of this as a game, and we actually do have a game for this. And the goal for this game, for the QCs to win the game, is to basically complete as many Band 1 programs as possible in the given semester. Those are the highest priority for the observatory, and so the observatory wants them done. And so Band 2 and Band 3 are really filler programs, with Band 2 being given slightly higher priority than band 3, but it actually comes at a cost, which I'll mention in a couple of minutes. And so, when the QC is scheduling these plans, they first look at, okay, what band 1 programs can we get done in the night, put them in. Then it's, okay, what can we use to fill these gaps in the program that we may see? And some nights it's awesome where you have just a 8-hour MAROON-X transit, and you're just like, all right, we're done with one program. Now we have to make something back up for when the MAROON-X transit gets clouded out. Or we missed the start of the window, so we have to just go do something else. And so for those filler programs, however, and for band 1 programs in general, if you want your program completed, there are a couple things that we tell you to do as context scientists, or what the context scientists would tell you. Number one, have your program prepared early. If you have your program done right now, kudos to you. You may get scheduled because at the end of the semester, sometimes there is just a lack of targets from the previous semester, and the QCs start looking at the next semester, just being like, all right, are there any programs that are done right now that we can just slip in here and get them scheduled? So that can be
Zach, I'll mention apropos of that, and it's probably relevant to the crowd here, that we are, as of tonight, very close to finishing 2 band 2 25B programs, because they got their observations set up very early, way ahead of the phase 2 deadline. And we've also had a really awesome winter, spring, early summer on Maunakea. So we are finishing up band 3 programs in like the best conditions. Tonight was IQ 20 and CC 50, so best seeing possible and no clouds. Band 3 was from 25A was getting those data, and band 2 from 25B was getting those data. So it's not always that band 1 gets priority. As Zach said, it's a very complicated calculus. And there's these slots that if you are vigilant, you can take advantage of. And there's other things that we can talk about later about setting notes and making your program more schedulable that can really help you fill in these cracks.
Well, and on that note, one of the things that I was about to mention is, for your programs, the ones that allow for the worst conditions generally are the ones that get the most time. Because, if you don't need IQ 20, then you can put it to IQ 70 and get a lot more access to the night sky given the conditions. And this is kind of where, the band 2, band 3 boundaries comes in, because generally for band 3, we do ask for, there is a strong push within the tax to basically say band 3, you should or band 3s are probably mostly a little bit poor weather proposals. They're generally, IQ 85 proposals. There may be the occasional really good weather needed band 3 proposals, but those are not the band 3s that are going to get completed. The band 3s that have the most success give the most flexibility in scheduling conditions, so they take generally worse conditions than band 1 programs, and those are the ones that can that can get completed. And because within the Gemini software, you have the ability to schedule a band 3 program that has worse conditions. I think it sometimes slips through the crack for band 2 proposal PIs who may have a band 3 program, but now they're in band 2, and so they have the better weather conditions. But maybe they have a band 3 program that could take worse. And in that case, if you're band 2, if you're originally your original proposal was for IQ 20, CC 50, SB 20, or whatever, that will be what goes into your band 2 proposal. But if your proposal may take slightly worse conditions that you had put in for a band 3 proposal, there's a trade-off there. You get the slightly higher priority from the band 2, but the band 3 conditions may allow your proposal to be scheduled a little bit better. And so That is definitely when you're thinking about when you're writing the proposals, that is something to consider as well. And
Zach, so
so,
I'll just mention that for everybody here, so the conditions that you've requested in phase one don't have to be the ones that you asked for in phase two, that you set in phase two. You can ask for worse conditions. And so it's very worth, you can't ask for better conditions, but you can ask for worse conditions. And so it's very worthwhile to go through the ITC for your science target. So never compromise on science, that's for sure. But you may be surprised if going like to CC 70 versus CC 50, it's not that much attenuation. It's, 0.1 mag, something like that. And so the signal to noise, you open up 20% more time on Sky, on Mauna Kea or Serapichon, and at the cost of 0.1 mags extinction. So it may be in many cases that your science can handle that. And you can also put in notes, so you don't necessarily have to formally change the condition constraints, but you can put in notes and say at QC, I am willing to flex to worse conditions. I would prefer, of course, my conditions that I propose for, but I'm willing to flex to worse conditions, and that works a lot of the time. And you kind of get best of both worlds there, because majority of the time you're probably going to keep with the conditions that you have, but you allow some flexibility for our Q coordinators to be able to move you to a different variant. And so you kind of go in these gray areas. And that's really, really helpful for Q coordinators to kind of shift things around. So as Eric said, talking with your contact scientists, they're your first line of defense. So whether that's an NGO or that's a Gemini staff member, we can help you go through those ITC calculations. We can help you fashion the notes that are going to make your program more schedulable. That's going to get you a higher percentage completion. Thanks.
and I will add on to that, you can ask for worse conditions. The only thing you can't do is you can't ask for more time. So you get the allotted time that you've been allocated, but you cannot. So you can't say, okay, I'll take CC's 80 if I get 2 more hours.
Well, you could ask.
It would be an immediate no.
Thank you.
So, so yeah, but within that, as you can see at the bottom of the slide here, the typical band 1, band 2 completion, band 3 completion rates are 70, 50, and 30. But if you actually look at the band 3 programs, if you need all of the data in your program to be taken in order for the science to be successful, you may not want to have a band 3 option. Because the big thing with the band 3 is that you may not get your program completed, but you get a lot of time, but you may get a lot of time taken for your program. Myself, for example, I have had a long-running speckle program that has been the perpetual band 3 program, unfortunately. But I ask for 20 hours a semester and I get 10. And I am happy just with people observing my stars. So, it really depends on the science case on whether or not band 3 and getting partial completion of the program is helpful. So we'll get to that question about the notes when we start looking at the OT. But I think that's it for this slide, I think. Oh, and then the game. I don't know. Are there any copies of the game being floating around still?
We have a few copies here, Zach.
Last I heard there was
They could be
14 of
shared
Gemini
at
North.
request.
Last I heard there was 14, and that's the only thing I've heard. Anyways, so there is a game floating around. And it's a fun game. I can't play it because it's too close to life. So it's a realistic, well, game realistic sense of how the queue system kind of works and the stress of trying to complete as many band ones as possible, especially if you get clouds the entire semester. And so yeah, if you're at AAS or at a meeting where Gemini is, stop by whatever booth or table or whatever they have there. They may have the game, they may not. I have no idea. So I think that's it for me.
I think we do have a question. Zach, maybe I can read it from Vasha. Hello, do you please clarify exactly where one can mention that one can use the plural CC, like while submitting the proposal in the pit? Would you like to take that question, Zach?
Well, I think that would be better just at the when we start showing the OT, I'll show a pit as well and show that.
Yeah. Okay. Yeah. But maybe I will add just the another way to do it, or a proper way to do it. Maybe it when you submit your proposal, right? There's this process band 3 requirement. So usually, like a proposal, the tech would try to put your proposal in like band 1 or band 2, right? But if somehow they use up all the time, your proposal is not ranked high enough, you can also put in this band 3 request. And then in there, you can relax the condition and say in your band 1 or band 2, you want a CC 50. But then in band 3, maybe you can say, I can take CC 80. And then you can say, I will need more time. I will need maybe 50% more of your observing time. You can do that during phase 1 as well. Yeah.
Yeah, that's what
Yeah.
I was gonna share. Do you just can I share my screen real fast? I'll share
Oh, yeah,
just share the
sure.
pit real fast.
Sure.
Because this is just something that we can that I can simply let's hear. All right. So yeah, so here's the pit. And so you have the general layout. So this is on the time requests tab. There is a consider for band 3. And this is how, and this would be, you select yes, and now it has a band 3 request down here. And you have to basically create 2 proposals kind of in here. And you can specify, for the band 3, these are the conditions I want. Now, if you don't want to consider for band 3, but you think it could, if you think your science can just have worse conditions, I think, going to the lowest possible weather conditions that you can still do your science at, I think is the smartest choice, because that guarantees you the best chance to get observed. So that's what I would, if you don't think your program would be band 3 compatible, that's how I would do it within everything. Okay.
Zach, if I can mention, there's also band 4. Just a suggestion as well is that if you could really use bad conditions effectively, as long as the dome is open, that's also an option.
Yeah, in band 4, the requirements for that is that I believe it's IQ has to be IQ any. Well, basically, yeah, IQ has to be IQ any, or CC and SB have to be any. I think that's it.
Sounds
I
about
think
right.
the actual definition is on the webpage. It's actually not that bad, but in reality, it really depends on the semester. But the good thing about poor weather, like band 4, is you can submit it anytime, right, within the semester. So it's up to the head of science operation at Gemini North or South to make the decision.
And I will say for that, there are some times where there's just a lot of band 4 programs already in the queue, and they may be like, come back in like 2 months.
I think we have a question. Asha, wanna go ahead?
Yes, I was just asking in case there is another separate place apart from just consider for band 3. That's what I've done in the past, but you mentioned if you don't want to be considered for band 3, but you can still use a little bit worse, then would you just recommend putting those worse conditions while calculating your exposure times, or is there some other comment we can put somewhere else?
I would honestly, like, if your science can take the worst conditions, I would just go with the worst conditions.
Okay. While doing the ITC.
Right, because then, it depends. If you're looking at it and it's going to take, 50 hours to do it in one condition versus, 10 hours in another, then that's definitely, something where you can be like, all right, time out a second. Let's go with the better ones.
Right.
But if that could be what you do. If you mark it as, if you do go in and you mark it as a band 3 program, you put those worst conditions there, you could ask for 50 hours of time in band 3,
Mhm.
and the 10 hours in the band 1 or for the band 1/band 2 proposal. That is something you could do.
Okay. All right. Thank you.
Are there any other questions, or we can go back to the presentation?
No more questions in the chat at this time.
Okay, great. Michelle. And Doc, anything else, or you're done? Okay, I guess then you're going back to me. Then we'll just talk a little bit more about afterwards, what are the things following there. Getting help. Yeah, we try to make it as transparent as possible, but as you see, the questions do arise, and sometimes there's a lot of edge cases you would like to have clarification. So here are the places where you may be able to get help. So the first place, of course, is the Gemini website. We have a very extensive website with lots of information. Yeah, so go through the website, the documentation, each instrument, we have very detailed documentation. Should be the first place to check. And then after that, if you have an active program, your primary contact scientist and the secondary contact scientist is really your best resources. If you are from a partner country, usually the NGOs would be the primary contact. And so, yeah, I would say when you reach out to them, please make sure to email them both, put them both in CC, just in case one person is not available, the other person will be able to help.
I'll let you know.
And if you still have questions, you can submit a help desk ticket. And so the website is there. It's really, you can ask kind of anything, kind of proposal preparation, time allocation, data reduction, and all the things. Eric says, and it usually first go to the NGOs as the first person. Then if they can't help, they will escalate to Gemini staff. So the only other thing I want to mention about the help desk is we do have a quite extensive label, like what type of question you have, like dragons or observing. Just make sure you select that properly, because otherwise it might go to the wrong person. So then it might get stuck there for a while. If you didn't hear anything, please feel free to ping the help desk system again, and then you will go back to top of the list. And we really try to respond to it as soon as possible. And then lastly, we will some of us will be present at the AAS meetings, CASTO meetings, Gemini Science meeting. Pretty much every AAS, winter AAS, we will organize some like special sessions and town halls. So you're welcome to find us there as well. Any questions on that? All right, if all good, yeah, I guess we need to move along so we can see all the phase 2 example. Oh yeah, exactly. So phase 2 preparation. So, and we said the phase 2 deadline for 25B is actually this Friday. So Brian already demonstrated the quicker you get it done, the faster you can get your data. And then just want to say July 18th, I really see at the time you need to set your observation for review. So the contact scientist will be able to check the observations, and they will still be working with you actually in the coming days or weeks to get it ready. Because officially 25B starts August 1st, right? So there's still some time like before the actual start of the semester. But still, you are encouraged to get them done as soon as possible. And yeah, please feel free to email your contact scientist because we are here to help. There's a lot of resources. There's actually OT tutorial video available on the website. We also have phase 2 checklist, and this is a more general phase 2 reminder and to help you get started. See, yeah, let's see. Okay. In terms of phase 2, the one thing is kind of worth highlighting, is if you want to eavesdrop your observation. So it is offered for both band 1 and band 2 programs. So if you eavesdropping is kind of like what we're doing now, but the observer will share the screen with you the whole time. So you can actually do your observation. So if you want to do that, you should add a note there says you want to eavesdrop, and then indicate like the contact information. And usually the observer will call you about 10 to 15 minutes before the slew of your target. And then they will share the observing screen with you. And then basically for most of the instrument, your data is instantly available in the archive. The good thing about eavesdropping is you're really there, right? So you really know exactly what's happening to your observation. And then for certain like complicated cases with target acquisition, it'll be helpful to have the PI actually being there, be like, yes, we are on the right target. It's actually used quite a lot for like TOO or rapid TOO observations. So because yeah, those cases, it just will be really helpful to know like we're actually on the right target. Any questions there? Okay, if not, I think that might be. All right, sorry, one more, one more. Yes, one more slide on my part.
Okay, yeah, okay, let's go to Igrance 2 Sky. That's good.
Okay, last slide on me is about science. And once you actually get the data, then it's phase 3, and you will go into data reduction, right? And so again, once you get to the data, you can still email your contact scientist if you have any potential issues with the data. And then the observatory do have data reduction pipeline ready. We are actively working on dragons, which is really what we are moving towards. But the dragons do not support all observing mode. So right now it's really only the imaging and also GMOS long slit and the GNRS long slit. So in the coming months and years, we hope to migrate dragons to support all the mode. But we're not quite there yet. So for some of the instrument, we still have the Gemini IRAF-based data reduction, which is available for all the instruments that now covered by dragons. And then for some of the Vility instrument and some of the facility instrument, we actually do provide reduced data product in the archive. And it include Lopeke, Zorro, MAROON-X, Igrance 2, and the Ghost. So in that case, that's actually really nice because your data will, your reduced data product basically will be in the archive. And then if you have any questions, again, make sure to submit a help desk ticket. And then like the staff will get back to you as soon as possible. And another thing is there's also an open source Python data reduction code called Pipit. I actually used it quite a lot for reducing GNRS, Flamingos 2, and also GMOS data. It actually works pretty well. It's a community pipeline, not developed by Gemini, but it still works pretty well. Okay, let's see. Right, Zach had a comment like Lopeke and Zorro reduced product are also available at NASA and EXO.
I don't even think
Okay,
they're on the archive.
We in position?
I see. Okay, so it's not actually in the archive. Yeah.
Oh, sorry.
The raw data is on the archive. The reduced data products, I think, are just on ExoFop.
I see. Okay, but I know for Ghost, it's actually hosted in the archive. Yeah, so the flavor is a little bit different for different instruments. Yeah.
I think that's the same thing for MAROON-X. I think MAROON-X also has yet to migrate to the archive.
Yeah,
But
that's correct. Yeah.
if you want any of the reduced data in this past proprietary period, you just email the MAROON-X team.
Right, that's correct. Yeah. Okay, I think this is the last slide about Shadow the Scientist. Brian, would you like to say something, or you're too busy?
Yeah, so we're just so sky brightness is rapidly changing right now. So I'm just taking the last calibrations of the evening. So maybe I'll just pass to Jamika because Jamika knows more about shadow than I do at this point.
Great.
You don't mind jumping in, Jamika?
Absolutely. I'm so very happy to. Yes. So Shadow the Scientist is an amazing program. I'm very grateful to be the programs manager of Shadow the Scientist. And as I said in the introduction, we are an initiative that's based out of the University of California, Santa Cruz. And we aim to offer immersive virtual learning experiences for scientists like you, but primarily for students of all ages that really spark their interest in STEAM careers and strengthen the foundational skills and knowledge necessary for success in those professions. We also host sessions that are open to the general public to foster community awareness and appreciation, value for vital research that are happening across STEM fields. In our sessions, as you're experiencing now, our participants are able to engage with university and industry professionals while they're exploring these STEAM topics in order to understand how they really relate to real world issues and community challenges and how those are accomplished. If you are at all interested in being a host for a Shadow the Scientist session, being a science host like Zach and Siyi and Denise and Brian and Eric, you can contact Brian Lameau, absolutely, or myself as well too. Brian was one of the co-founders of Shadow the Scientist on Maunakea. So he's done, I don't know, almost 100 sessions on various observatories with Gemini, CAG, Subaru. We just had a session with the Magellan Telescope at Las Campanas last week. So you have lots of support with you. I take you through the whole process for planning and execution, promotion of sessions. So if you have any questions, I'm going to put my email in the chat. But Shadow the Scientist is making an impact on lives every day, and we've had over 4,200 participants to date. Thank you.
Wow, that's really impressive. Yeah. This is actually my first Shadow the Scientist. So far, so good. It's been fun. All right, with that, I guess I'll stop sharing. If there's no other questions, we will do some live phase 2 demo. So I'm going to hand it over to Zach, who will get started.
Oh, I get to get started. All right. All right.
Show us how it's done,
So
Zach.
what?
Show us how it's done.
All right. Let's see here. Which one do I want? I want this one. All right. So you all get to see that I have also not done my phase 2. So, so this is my program. And as you can see, there's nothing filled out here. Well, I guess there are 2 observations, but I haven't done anything with them. So yeah, so I'm going to show you some how to set up Zorro observations, and then also how to set up one of the modes for Ghost at Gemini South. So if you get an accepted Gemini proposal, you'll end up with a program that kind of looks like this, minus a couple of things on here. You'll basically have just your title slide up here, completing phase 2, and then templates. And so basically everything is kind of set up pretty nicely within the template area here. So if I go into here and I go to, let's start with the Zorro one, you can see that all the targets that I propose to observe with Zorro over here, that gives the conditions in the middle column, and then the time request that I asked for on the right. And so let's just start applying some of these. So you go down here to the supply button, and you can see that all of them are checked off by default. I'm not going to do that. I'm just going to do one. We're going to do this guy here, and then click OK. And you can now see that there is a new template that has just popped up. And so if I go into here, you have visitor instrument observation, because Zorro is a visitor instrument. And here is the instrument panel for Zorro. It may kind of look familiar to some of you. And for Zorro, you don't even technically need to do this, but I will, because for those of you who are familiar with ALPEC and Zorro observations, the NASA Speckle team is the one who observes these programs. And at the end of the day, what they will follow what you put in here, but you can also just say the team can observe how they see fit. Meaning that there's a couple different, for ALPEC and Zorro in particular, there are some nuances to observing where if you don't, with ALPEC and Zorro, normally there are a lot of targets that are observed, and they can be taken in different conditions. So when you set up your proposal, actually, let me go to this screen over here, because this will actually show it better. You can see that there are a couple of different sequences or different exposure times depending on these conditions. And generally what I do for my programs is I'm just basically say, okay, observe what you guys think is best, and then we can deal with the time allocation at the end. But if you care about the time allocation, you can actually you can put in here how much time you want spent. So for this target right here, which is this guy, it has a, I'm going to actually change it to just the whole screen here so you can see actually what I'm doing. All right, is that sharing now? I think it is. And so this target here has a V of 13.46. So this is right about here. And I asked for CC, or what did I ask for? CC70, IQ85, so that would be here. So about 14 sets. So that is what I budgeted in my phase 1 time request. So here it would be 14 times 60, which I can't do math in my head right now. So da, 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 da. Da, da, da. All right, it's 840 seconds.
Okay.
All right, so you plug 840 seconds into there. And you sync. You should be syncing relatively frequently so that you don't lose all your saved stuff. And so that's pretty much all you have to do for Zorro. So here is my Zorro observation set up. One of the things you may have to do is you may have to choose a better guide star if let's see here. I want to go to this one now. You may want to choose a better guide star. So here's the image window. So for this star in particular, it actually has a pretty good guide star over here, but sometimes there may not be a lot of guide stars available, in which case for Alpec and Zorro, you can kind of push it in a little bit. You can see here, this outline here is the P2 vignetting. And for Alpec and Zorro, the field of view is really, really small. It's going to be like 7 arc seconds, so you can kind of push this in. So nominally for Gemini guiding with P2, you generally want to be outside this circle right here, this yellow circle, and then within the green line out here. But for Alpeke and Zorro, you can push it in a little bit. Like this red star here, if we absolutely needed to go to a different guide star, this one conceivably could be one that we go to. But for the most part, this shouldn't be something that you have to deal with. And if it is, then you can also just email your contact scientist, and they'll know what to do. The last thing that you can do if you want to make the life of your contact scientist for Alpec and Zorro a little bit easier, and you don't have a ton of targets, is for each Alpec and Zorro observation, you need a point source standard to go along with it. And generally what happens for speckle programs is the contact scientists will take if you have a really large program, or, well, actually anytime, they'll take the point source standard, or they'll take your proposal, you'll take the speckle programs targets, and they'll generate a list of point source standards for you. Or you can do it for yourself. We now have that option on the Alpec and Zorro webpage. This is through, let's see here. So you go to the Alpec and Zorro webpage, you go to calibrations, and then you go here. You can search for your own point source standards, and basically we just want a single star that's nearby. And so you would put your target information in here. So I'm just going to call it target 1. We're going to just copy paste everything over real fast. Oh, come on. 2000. Proper motions. Magnitude doesn't really matter. So I don't care. It's just going to be 0. And then if you search, and it spits out a potential point source standard that you can then put in into here. And to do that, you would just go to observation. You would do a visitor instrument observation. You you would want to set it up with the same conditions and stuff as your science. You would then put this target in here. So this is HR 7745. And then you can do this helpful little search thing here, and that will spit the target stuff into here. And it found a guide star. That's good. Sync again because it's telling me to sync again. All right. So here is your standard star observation for your ALPECA program. Now, one of the key things that you will see in here for the speckle programs, and when you do these point source standards, is there's now a giant X next to this. And the reason for that is because you are adding well, it says it's 2 errors. I don't know why it's 2 errors. Oh, okay, I'll have to go in and change that. It's giving you an error that it doesn't match your phase 1 coordinates because your target was not in there. It was not in your phase 1 pit. So you'll have to email your contact scientist about this, and they'll have to email the head of science to get it approved. And so that's pretty much the fun times with ALPEC and Zorro. If you have a lot of targets, you don't need to do this, the standard star step. You can email your contact scientist and be like, hey, I have 500 targets. Would you be willing to run this in bulk using the code on the system? And they'll be like, yeah, sure, let's do this. And so for the most part, this is not something you can worry about. But if you only have a couple of targets and you want to make their lives easier, or if you really care about what your point source standard is, then you can go to the Gemini webpage. The ALPEC and Zorro webpage is on the Gemini webpage and do this. And now, after you've done all of that, what you do is you now go into here and you say for review. And I'm going to go down here too and say for review. And then you sync, and this will now send an email to your contact scientist, and I think it also sends it to you. I can't remember whether it sends it to you or not. Okay, it does. That says you have set something to for review. And I also typically like to send a email just in general to the contact scientist, just being like, hey, I did this. Let me know if there's anything I did wrong. And then start that email chain with them. All right, that is ALPECA, or that's Zorro. So let's go to Ghost, because I don't know whether there was actually anybody who uses Zorro, but I thought I would go through it. But there's probably some people who are using Ghost. So, Ghost. My program may look a little different. As you can see on the template here, there are 3 things for each target, mainly because I want to RV monitor these systems over the course of the semester. So I'll go into a little bit of how I would set that up, but it can be different. Oh, and the last thing for the Zorro thing is for ALPEC and Zorro programs, you need to have a configuration note that just says what you want the instrument set in. So I typically add something like this, but if you want specifics for the instrument, that can be set up there. All right, back to Ghost. So I'm going to do the same target as I just did there, this L350-82. So I'm going to just click. Okay, so it generated 3 different things here. Now I'm actually going to combine them all into one, is what I'm going to eventually do. But I'll set up one and then I'll basically and then I'll combine everything later. All right, so this is what Ghost looks like. That's not what I wanted. This is what the Ghost instrument page looks like. So there are a couple different options here, depending on what you want, what your science case was, and what you propose to do. So the resolution mode, you either have high resolution or precision rate velocity. I don't think the PRV is up and functioning yet. I'm glancing at people.
Yeah. I don't think so. I think it's still being like commissioned. Yeah.
All right, so you only have basically high resolution or standard mode. And so for me, I was doing high resolution, or not high resolution, standard resolution. And then for target mode, you have 4 possible options. You have single target, dual target, and then one target, one IFU on target, one IFU on sky, and then the opposite, depending on which IFU you want on sky versus target. I'm going to go with this one here. And then you basically set up the program as to how you set up the program within the PIT and within the ETC for Ghost, which is right here, or the ITC for Ghost. And so for my particular program, I found that I needed 900 seconds for the exposure time here. And so one of the things also is that the Gemini staff recommend that you keep the read and gain settings to what they are already. So for the red camera, that should be medium read, low gain. And for the blue camera, that should be slow read, low gain. And that's pretty much it for for setting it up, at least for my program. So I know this is kind of like, oh, this is easy for this, and you may have more you may have a little bit tougher time if you're doing other modes and different exposure times. I would encourage you to check out the Ghost OT video, which is available through the Ghost page as well. If you just go to the general Ghost page, I think it's like, it's not there. Where was it? I think it was observation prep. Yeah, observation prep, and then I just clicked on that to open up in a separate window. But Emily does a good job of going through this and showing off how you're supposed to set up everything for the different sets. You can see over here. But so if you have a dual target or off axis, I would really encourage you to go check those out, because I don't know how to do them, because I haven't had to do them yet. So I would encourage you to go check those out. So going back to this proposal, I'll
We're all good.
to this program, I'll start to finish up this. So you can change the spectral and spatial binning over here. I already had it set at 1:1, but you can go up to 4x4, 2x8, etc. If you need fiber agitation, they're down here. ISS port, I think, will generally be up looking. And for the most part, I don't think you need the change. That would be something that the contact scientist would probably flag you on if it changed at some point. But my understanding is that Ghost will primarily be up looking from the up looking port. And so if you need, one of the things also that they bring up in the video is that if you need exposures or different exposures, there are two places you can modify it. So if you look at the sequence here, I'm just taking one exposure for both the red and the blue cameras, and that's what this says here. But if you need more exposures, generally it is recommended that you change this down here rather than this up here. I believe it's for reasons with the fits, with how the fits files are compiled. And so that's explained in the video a little bit more. So if you want to learn more about the exposure counts versus the observe, please go check out that video. Okay, so I think this one is done. I don't think there was anything else. So one of the things that I mentioned is I wanted to do radial velocity monitoring. So I'm going to change this now to basically what I kind of have it above, which is I'm going to change this observation group to basically contain all the Ghost observations for this particular star. And so I'm actually going to just set this for review. And then I'm going to take this, I'm going to copy, I'm going to paste, I'm going to copy, I'm going to paste. I could have just copied and pasted the other one that was already in here. And then I wouldn't have to do this because I just want more work for myself, apparently. So that one's now set. And then this one down here, I need to change as well. All right. For review. All right. Oh, actually, I can't change the name now that I did that. All right. Never mind. I have to set these back because I was going to change the name for these. All right. I can delete these two now. Delete. All right, so now I have my 3 observations in one observation group. So I'm actually going to label this now as observation 1. I'm going to label this as observation 2. And I'm going to label this as observation 3. And so basically for my RV monitoring of these systems, I don't want the targets observed on the same night. Or I don't want, sorry, I don't want for a given target, for a given star, so let's say for L350, I don't want 2 observations on the same night. I wanted them all separate nights. So what I'll do is I will add a scheduling note. And I will say, please, let's hear at QC, please do not observe more than once per night. And that will let the QC know, hey, this program really wants basically these observations over the course of the semester, not on the same night. They can be on sequential nights, but not on the same night. And so now I will set everything for review. Where am I going here? And there we go. So that is my ghost observations all prepared. Oh, I forgot to show one thing. As this is this is a IFU1 on target, IFU2 on sky, I'm going to show you where the skies are. So here you have, let's zoom in. I don't know how well you all can see this. I'm going to actually change the share screen to just be this. So here you can see the positions of the sky and the positions of the IFU. So you have the IFU on target, and then you have the sky over here. And basically, you want to check. You want to just go look in this in this image button up here, just to make sure that the sky is on sky. Because sometimes, I mean, stars are everywhere, right? And stars and galaxies are everywhere. So there could be something on your sky if you're not careful. So just going into the image and just checking, okay, is there a thing on the sky? And there doesn't appear to be, so that's great. Now, one of the other things that Ghost has, it does have a dedicated sky fiber, and actually the proper motion of my star is terrible for this. But you can see this blue dot right there. So there's a dedicated sky fiber next to IFU1. And if you want to change, you can change the angle of this. And that's what this, if I go back now to the OT, that's what, if you go into Ghost, that's what this position angle changes. It changes the position of that sky fiber within the fiber bundle by rotating basically the fiber bundle. And if you care about, for us, or for my program, we have another sky fiber dedicated to sky. So we don't need to worry about that. But if you did want a sky from this particular fiber, or from this particular, let's see here, that's not what I wanted. From this particular spot here, then you may want to rotate it so that it's as much not on the target as possible. And so the way you do that is by changing the position angle. But for most observations, the team recommends that you keep the position angle at 0. So if you have to change it, you may want to check with your contact scientist first, just to be like, hey, this seems fine. So yeah, so I think I'm checking this out. I think this may be fine. I also added a Ghost RV monitoring scheduling note up here as well, just as an extra reminder. Hey, don't observe them more than one night or more than once per night. But I think that's it for Ghost. And there's a question. You see 2 templates for Ghost. One says Ghost Science. Huh. Is that? I'm kind of confused on what that is.
Yeah, so they both look, there's 2 templates. One says Ghost Science, the other says Ghost Observation. I can open them up and put the exposure times, and it said in either one.
So is it after you apply the template or before?
Well, I probably made a mistake and I probably didn't apply the templates correctly, but I've ended up with these two parallel things.
Yeah, because I see ghost science here. I don't see ghost observation. Oh, wait. I wonder if is that what you did? Did you make
Well, I'm not sure how I got there,
okay.
but if I've got two templates and they both have the same information, I can just pick one, right? And
You should be able to pick one, yes.
I've filled them both out. I'll save them as an XML file and then pick which one I think is appropriate and let the contact scientist tell me I was wrong.
I mean, so if you're normally for the templates, I don't do anything up here. I don't modify. I leave this as is. And then it's after I apply everything that I go in and I start changing things around down here. Because up here, so, you know, if you're changing the exposure time up here, unless the exposure time is the same for all of your targets, that exposure time will be applied to each of your targets. The template will not change based on whatever your phase 1 time request is. It will be whatever time is in this here. So if you notice when I applied the template for this target down here, I mean, these were all 300 and I had to change them all to 900. Because the 300 is what is set in the template. So I would be wary about changing the template observation.
No, I'm only changing the individual
Okay.
for each target. Yeah.
Okay. Yeah, I mean the only way I get a ghost science or a ghost observation is if I go into over here and I create an empty observation.
Mhm.
But I mean they both should be the same.
Yeah, I think I may have loaded the library templates inappropriately or something.
Yeah, I mean like
Cool, Denise.
I mean as long as it, you know, when you're
That was running.
in the targets that you're setting for review, as long as that matches what you put in the phase 1 proposal or what you want to do for your science, then I don't think there's a problem with it.
Yeah, it will. Yeah. Okay, thank you.
Any other questions?
No other questions right now.
All right, then I will turn it over to CE for some more fun times with the OT.
Well, thank you, Doug, for the really nice demonstration. Okay, so if you're still with us, for the next part, I just want to show you how GMOS long slit point source observations gonna be. Yeah. So let me share my screen. I'm just gonna share the entire desktop. Yeah. Sorry about the messiness. But anyway, so when you open OT, right? I'm gonna start with the basics. This is kind of what you will see. And then as first-time user or you have a new program, you really should do manage keys and input your program information. So you can see as a staff, I have superpower. So I have a Gemini North and Gemini South staff key.
Thank you.
But then whenever you get approved a new program, you should register your program key. So I already registered since I don't want to show you my password. But anyway, if you have a new program, like you should just do the plus sign, right? And then taking a while. Anyway, to register your program, then that will give you access to your particular program. So right, I'm going to stop here and oh yeah, okay, finally. Yeah, so basically it will be like a program key. And then you would have your program ID and the password from the announcement event. Okay, so I already did that. So right now I'm using, make sure, because at a given time, only one key can be active. So make sure like you are actually using your appropriate program key. And all right, then let's open. So I have one program, which is Gemini South, GMOS. Yeah, so I have not done anything. So as you see, so when you open up a brand new program, this is what you would see. So maybe before we're getting started, I just want to re-emphasize a few key things that Zach already says. First is this sync button. This is really, really important because that's kind of how you sync with the observing database. So right now, this sign means it's good. But if you see any little like yellow arrows, please make sure to sync with the system before you do any changes. Otherwise, there will be like conflict of information. Okay, yeah. Then let's see. The other thing is when you open up the program, right? And just at this cover page, you can see a lot of information. And then see, this is like the information about the contact scientist. I guess since it's my program, look, I'm the principal and additional support for both programs. But then in your case, you probably will have 2 different contact scientists. So those are the people who will help you with the program. Let's see. The other thing, maybe at the PI, it's really important for you to know what's your program time, right? So this is, I mean, there's a lot of time here, but the most important time for you to keep in mind is this allocated time. So for this program, I am being allocated 7 hours and 22 minutes, right? Right now, I plan nothing because I have not set up any observation. So after I'm done setting up the program, my planned time really should equal to the allocated time or very close to. If my planned time end up being like 20 hours, my contact scientist, I guess me, will yell at myself, said, hey, you didn't set up your program properly because you only get 7 hours, 22 minutes. Okay, I think these are the basics, and then we'll get started. So we talk about all this template, right? So the first step you really need to do is apply the template to your program. So you see here, I have 5 targets. So I'm just going to apply all. Do here, and you see I have CC70, IQ85, and I have time for each program. So I just do apply all. And then here you can select. I think for that, he only applied for a few targets. But anyway, typically you really want to apply all, and you do OK. Then now you see there's a bunch of right? So the template has been applied for all your targets. And also, as you see, since I make some changes, you already see this sync button, right? That's different. So yeah, I mean, I feel like I probably do it excessively, but every time you see that, I would just click sync and make sure it syncs with the observing database. So my information will get lost. Right, maybe I won't sync so much during the video, but just please, as you work on them, please make sure to sync them. And then, so I also just want to take a little bit look at the file structure. So you see, I have 5 targets, right? So these are the 5 targets that have been applied. And also there's this baseline calibration folder. So if you open it up, this is the folder which we do calibration for this program. So in this specific case, there's a standard star, and then there's an arc taken with a standard star and the twilight flat. So these observations are not charged to your program. This is kind of, it's not directly charged to your program. And then these are done by the observatory. And it's typically 1 set of baseline calibration per setting. So in my observation, these are all like B480 grating observations. So that's why there's only 1 set of baseline calibration. But if your observation have like a few different ones, then there will be a few different baseline calibration. Okay, so now I just want to walk through you about how to set up a GMOS long slit observation. So let's take the first target as an example. So you can open it up. You see there's really 2 parts, right? So the first part is acquisition, and the second part is science. So basically when the observer executes the program, they will do the acquisition part first, then science, and then the program. So if we open up the observation, the acquisition, there's really not much to change, particularly for the acquisition part. I think the main thing I try to do is click on the target and make sure like the coordinate is correct. And then I will also just take a look at the field of view. So if you do click on the image thing, make sure the guide star is good. It's green means like the automatic guide star works.
Oh, did we lose C?
I think so, possibly. I'm sure she'll be right back. Can someone
Let's give her a second to come back. Just as she was getting to the best part, setting up the guide star.
Yes. Oh, you're back, CE.
Okay, I was about to message you guys that my computer just got frozen. Okay, maybe, okay, am I back?
You're back. You're totally back. Yep.
Okay, wow, okay, it could be the OT or something. Are you still seeing my screen?
Yeah, we can still see it. Yeah. Yeah.
Okay.
There's a bad guide star C, obviously.
actually loads of star. But what I'm trying to say is, well, imagine you're seeing a background star field, and then this is my target. And then the automatic guide star system actually find a pretty good OI guide star, right? So, I mean, you can't see it here, but anyway, so it's green. So then you don't really need to do anything. But sometimes, because this is the patrol field of the OI guide star, sometimes there's not really a suitable guide star here. Then what you might need to do is change the position angle of your science observation, and then maybe there will be other better guide stars there. So you can do that by changing like this position angle.
See, I don't know if it's just me, but the audio is coming through a little bit weaker now. I don't know if your like microphone flipped or something like that, but it's a little bit harder for me to hear you now.
Right, say it again.
Actually, it sounds much better now. Yeah, the audio was just a little bit weaker, and
Okay.
maybe your microphone had switched or something like that. But
Yeah. Okay.
now
Okay.
it
I'm
sounds
glad.
great.
Well,
Now it sounds great.
okay.
Yeah.
Okay.
Yep.
Awesome. Okay.
Thanks.
All right, then we'll continue on. But in case you're curious, and you can look at the sequence. So this is basically our acquisition sequence, right? So as a user, you don't really need to change anything. You just need to be aware of the guide star. So and the next part is the science part. And then similarly, this is the target component. So you just want to make sure this target component of your science kind of agrees with the acquisition sequence. So if you don't really need to change anything, then I don't think if you didn't really change anything, then you don't really need to do anything. But I think a bigger part you may want to think about is here is the exposure time. Like what exposure time you want to do on your science observation, and also what is the central wavelength, right? So that's the part which you actually will change. I think for now, I will just keep it like that. And then if you take a look at your sequence, so you see like, so I have a science observation, right? So I have 4 exposures and each is 5 minutes long. So like this is the science, this is science. And in between, there's actually some nighttime like on sky calibration. So there is an arc and two arcs and 2 flat taken at the same time. And then also our default template for the point source is and has a Q offset. The reason is because GMOS CCD have gaps, and then with a small Q offset, it will cover all the CCD gaps. So then like it will give you a continuous wavelength coverage for your science observation. So you see like the observing wavelengths, and so I have one set is 0.52, 520 nanometer, and another set is 530 nanometer. So it kind of helps you give you a continuous wavelength coverage. Yeah, so I need to go back and double check what exactly is the exposure time that I did calculation for the science, but that's really the main thing you need to do. Yeah, so let's say
See, maybe it'd be a good time to show if you have a SED set and a spatial profile set. I use this all the time. The ITC spectroscopy and ITC imaging. This is such a like helpful tool while you're even like, you know, just tabula rasa. You don't even need to look back at your proposal. Just like what signal to noise do I need? And then you go on here. So yeah, if you don't mind showing that, that's awesome.
Yeah, sure. So this is almost a 20th magnitude. I think it's a point source. So it's a point source. It's a star, and so let's say just a black body of like 10,000, right? So once you put in this information, I think Brian absolutely right. So when you click on sequence and do ITC spectroscopy, it actually tells you what is the signal to noise ratio you can expect. Okay, wow. Okay, this is terrible. So I guess I need to increase my exposure time or double
exposure time there.
Exactly. Yeah. So see, in this particular case, okay. So thank you for checking and helping.
That's
so
for those 2 steps, right? And then
exactly
the other 2 steps.
exactly.
So like if you click down at the next one, 7 and 8, yeah, you see the shift, the wavelength shift, which is
exactly. So this is actually a super useful tool. So you see, like for 600 seconds, so basically 10-minute exposure in this particular case, I will get a signal noise ratio of 1.75. So that's probably not what I want. So I have to make some changes. But yeah, so this will be a very good thing just to double check, right?
Well, you can publish in Nature with that. See, it's fine.
Once I bring them enough and say, hey, those are 3 sigma detection. Yes. Okay, so assume you are happy with that, and as Zach already demonstrated, you should just set it to for review, right? Because as a user, this is the only stage you can set. And then when you do for review and sync, then your contact scientist will get an email about it and they will work on it. And assume the contact scientist is happy with the observation, they will put it to prepared, which means your observation is done and ready to be incorporated into the queue. So the idea is we really want to get your program to be prepared as soon as possible, but hopefully before the semester starts, which is August 1st. And I guess the only other thing I really want to mention is for your baseline calibration. Really, I think for me, I find that the most important thing is to make sure your GMOS setup really matches your science observation. So for example, like here, the central wavelength is 520, which is great, which is kind of exactly what my science do. But sometimes, let's say I've seen many PIs, they change the central wavelengths to be like 480 or something, but then they forget to change the central wavelengths of your standard. Because if you didn't do that, then you will really have problem when you run into data reduction. But otherwise, and then the same as for the twilight flat, you should make sure the GMOS setup agrees with your science information. So that's really the main thing. Yeah, I don't think I have anything else for GMOS. Any questions?
No questions in the chat.
Okay, thank you. Yeah. Yeah, maybe I will stop sharing here and hand it back to Jamika or Brian. Yeah.
Yeah, I can do okay, so we're closed up now, so I'm a little bit more chill. It's been kind of a crazy last hour after 4 hours of just taking photons. So yeah, maybe I can share more OT things. And this is so this is a program from 24B, Gemini South, that was a GMOS MOS program that I led. And I want to show this program just for a couple reasons. One, to talk about what I mentioned earlier, which is about really guiding the Q coordinator or the observer as to what you want, and to make your program flexible, and also to execute the observations that are most useful to you. Because as Zach mentioned, like he has this perennial band 3, and he gets half of the time, almost all the time. So he gets 10 hours, but which 10 hours, like which targets are being observed? And you leave that up to the whim of the Q coordinator, or do you help like guide the Q coordinator? And so you can set the order of priority for different observations in a blue note like this. So this is a scheduling note, and this is a note that the QCs will effectively always see in our Q coordination software. So this is something that'll flash when they're setting up the observations, and so they may modulate the observations based off of what you ask for. It's not for sure that they will, but you can always ask. Never hurts to ask. Another way that you can set the priority is with this priority button here, which is missed by a lot of people. So there's 3 categories of priority: high, medium, and low. This doesn't set the priority relative to other programs. So you can't say that my band 2 is higher priority than your band 2, but it works within the program. So generally, it's sometimes ignored, but generally it works within the program. So if you set something as high priority and something else as medium priority and something else as low priority, generally the QCs will pick that up and will take the highest priority observations first. The other thing that I mentioned earlier was about tolerance for poor conditions. So what some people call flexing. And so I mentioned here in this program in a red note, this should actually be a blue note, but this is an internal note for all of us, that says so these observations were accepted under IQ 70 CC 50, I think. And I just put a set of conditions where these observations are still acceptable. So IQ 85 CC 50 or IQ 70 CC 70. And then I say we prefer the observations, of course, to be taken under IQ 70 CC 50. But you can have a decision tree like this, and you don't have to actually, so I don't think I actually changed the conditions at all. It was always SB 50, CC 50, IQ 70. But I suggested to the QC that they could move this around if they needed to, even to a surface brightness 80. And then sometimes there's a disconnect between the observer and QC, especially when you do non-standard things like this, because we do really work on variance and we're contractually obligated to not give data that's worse than the condition constraints unless we have the express permission of the PI or their spokesperson. And so I would also write an observer note saying, don't worry about it. There's tolerance for poor conditions. We also have other things like, for example, when we do MOS masks, we have RMS of the fine alignment stars. So there's 4 to 5, well, depending on the mass, depending on the field, somewhere between 2 and 5 alignment boxes. And so an RMS is calculated with respect to the center of the centroid of the star relative to the center of the box. And if that RMS exceeds 10% of the slit width, and these slits were 1 arcsecond wide, then we are told by our acquisition software, hey, stop the observation and go back to your contact scientist. But you can actually opt out of that. And so in this case, I said, okay, if first thing for the observer to check is to clip out high proper motion stars. Of course, as a PI, you should be clipping those out or making corrections from the beginning. Our mask making software, GMMPS, will tell you when you've picked a high proper motion star, and so it'll warn you. And in fact, if the proper motion is too high, it won't allow you to include that star as a fine alignment star. But there's, of course, borderline cases. And if you don't make the proper motion correction and include it, then an observer might question why that star is in there. They might see the star at a different location than where they expect. They can ignore that star and then recalculate the RMS. But supposing that they're all the stars in your mask are kind of moderate proper motion, you didn't make the correction, well, then you would get a high RMS, and that would maybe we would ask you to remake that mask. But if you're okay with a 10% throughput loss or so relative to optimal, then you can put a note in there saying it's fine, please proceed, and especially better conditions than you request. You're basically gaining back the throughput. So it's good to iterate back and forth with your contact scientists about the language of these notes, because there is a certain language that Q coordinators have. There's a certain language that observers have. And so making them very, very clear, the contact scientist can help you with that. Thank you, everybody, for joining. Thanks to everybody on the science hosting side. Thanks, Jamika, for getting up at this crazy hour and hosting this session. And thanks to everybody for joining from all over the world. And it doesn't stop with this session. We provided so many resources, avenues for resources. You have your contact scientists. We're happy to connect you to all of those resources. If you forgot, we're going to post this online on the Shadow the Scientist YouTube page. So there's, we're here to help. We're here to bring the best science to the observatory through your guys' program. So please reach out, and we'll work in tandem to do that.
Fantastic. Thank you all so much. And we look forward to seeing you in a future Gemini users session. Take care. Aloha.
Aloha.
Thank you.
so much.
Bye.